All right, so we sort of left off in an awkward place last time, but we are starting on Unit 4B, I believe. We were talking about naming covalents and naming hydrocarbons and organics. So we just, at the end of the last video, we said, what is a hydrocarbon? It's a molecule with only hydrogen and carbon. So an organic compound still has main components are still hydrogen and carbon, but it might also have some oxygen. I mean, it could have other things like nitrogen and chlorines, and we'll talk about those. But the ones that we're going to deal with are going to also have oxygen. So the carbon atom can form, basically there's three different types of bonds. A single bond, a double bond, and a triple bond. So we could have a single bond, which we'd represent like that, a double bond, and a triple bond. And carbon has 4 bonding spots, which is why it can bond so differently. So when you see a hydrocarbon that ends in ane, for example, like ethane, ane tells me that's all single bonds. If you see ene like ethene, that's telling you there's at least one, double bond. And the same with YNE, ine, at least one triple bond. Okay. And so hydrocarbons can get a little tricky. I'm actually going to go off notes here in a little bit and do a few other examples. But remember, the longest chain determines the base word, the base of the compound, so or the root name. And we have meth, eth, prop, bute. Now it gets a little bit easier. Pent, hex, hept, oct, non, and dec. All right, so those are our roots. So there's a few others that we had, so that we're going to name. Any alcohol group, that means it has an OH somewhere on the end. We are going to name with something anol. Something anol, butanol. If a methyl group, then we're going to begin with the word methyl. If we have a carboxyl acid, so that's in other words when we have the carbon on the end attached to an oxygen with a double bond and a hydroxide ion with a single bond, then we're going to call it something anoic acid. If it's going to be in a ring, we're going to name it cyclo. If it's got any of the other functional groups, we're always going to put some numbers on it telling which carbon. And so we have all these examples. We can do those. And we'll probably go down to about here before we go on. So 3-octene, that's YNE. So oct tells me 1, 2, 3, 4, 5, 6, 7, 8. I have 8 carbons, and they're not in a ring because there's no cyclo. The 3 tells me the location of my double bond. If there were more than one double bond, I would say something like octdiene or triene, and then I would say oct 3,2-diene. So then we'd move the numbers. But for this one, when there's only one, we can put the number on the beginning. So that means the third, the 1, 2, 3 carbon is going to be where our triple bond is found. Okay, so now if we look at our carbons, this carbon already has 3 bonds. It can only bond 1 at a time on this side. Same with this guy. 3 bonds can only bond 1. So now we can look at the rest. This guy can get 3 more, 3 more, 3 more, and 3 more. All these would have our H's. And it's okay on your packet if you don't put H's on all of them, just leaving it left over. Oops, not there. Like this would be okay without the H's. But if you want to go ahead and put your H's. And so this is how I think it's easier to figure out the formula. So now I can count 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. And there is that quick rule of thumb for, let's write it up here, anes, CnH2n plus 2, enes, CnH2n, and ines, CnH2n minus 2. But that only works if there's only one ene bond or one ine bond. This way, drawing it out works every time. All right, 2,4-hexadiene. So hex means 6. 1, 2, 3, 4, 5, 6. That prefix is always telling us the number of carbons. Diene. So this is telling me that on 2, and then so on 4, we have triple bonds. And now we can go make sure all of our guys, let's see, have 4 attached to them. And so that means that this 1, 2, 3, 4, 5, 6 carbons only ends up with 1, 2, 3, 4, 5, 6 hydrogens. So you can see that that rule that we talked about up here isn't going to work because we have a diene, 2. All right, 2-heptanol. So hept, that's 7, and all means there is an OH. And it's 2, it's on the second one. So 1, 2, 3, 4, 5, 6, 7. We're going to find somewhere on our second one, we're going to attach an OH, not just an O, an OH. And then the rest of these will get all of their 4s, and I am going to be lazy on this guy and not actually write the H's, but each of those lines is an H. So we've got 7 C's, 7 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 H's and then the 1 OH. You could also write this either of those two ways. All right, cyclononene, and I don't know what nonane, excuse me, I don't know why I picked this one because it's going to be way big and I don't like it. So nona means 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at that. Good on the first time. And it's cyclo, so they're bonded in a circle. Notice it's an ane, so they're all single bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, like that in a circle. And then they each have to get 2. Oops, I'm way taking up too much space. 2. So I could write C9H18. Some of the extra hydrogens had to get kicked off in order to form that ring shape. Okay. 2-methylpentane. Well, pent means 1, 2, 3, 4, 5. Ane means they're all single bonds, but it's saying on the second one we have a methyl. A methyl means CH3. It's almost a full methane, but we're just attaching an extra CH3 to one side. And so now we can go ahead and put the rest of our bonds and make sure everybody gets 4. And even though there are 6 here, we call it a methyl because of the structure. If I just wrote the formula as C6H1, whatever, it's going to lose our methyl group. So sometimes you're going to see it written CH3, C5, then we can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Write it like that. You can combine those, but this lets me see it's a methyl group, but it is also just as well. We could write it that way. All right, totally running out of space. Propanoic acid. Luckily, prop is just 3. So 1, 2, 3. And let's single bond them because it doesn't say anything else. And we're going to give the last guy on one side or the other the double bond to an O and a single bond to an OH. And then 1, 2, 3, 4, 5. So this would be C3. Then 1, 2, 3, 4, 5 H's, and then I could do OOH. Or I could combine those and say C3H6O2. So naming the following. This guy, I don't know if you guys can see on this, but you should be able to see if you're looking on your paper. This is 1, 2, 3, 4 C's, and they're in a circle. So this would be a cyclo, and 4 is butane. Cyclobutane. All right, so 1, 2, 3, 4 C's. Once again, that's bute. But now, do you guys see the double bond right here on 1? So it's a 1-butene. 1 because it's on the first one, and ene because there's that double bond. All right, here's a C with an O, double bond to an O and an OH, just like this acid right here, except we've got fewer. So instead of a propanoic acid, we now have a methanoic acid, because there's only one C, and meth is the prefix for, or this, the root for 1. All right, this guy looks crazy, right? So we have 1 sticking out over here, 1 over here. We're going to name the longest chain, and so let's count 1, 2, 3, 4, 5, 6. 6, that is hex. And oh, we'll see 1 double bond, 2 double bond, 3 double bond. So we could name that triene. And we could put the, oops, I didn't leave space. We could put the, it's on the 1, on the 1, 2, 3, 3, and then on the 1, 2, 3, 4, 5. So hex 1, 3, 5 triene. But what's this guy? We haven't included him. That is our methyl. I seriously doubt you guys will ever have anything as complex as this, but definitely these simple structures, you should be able to name them. All right, so we will stop here and we'll continue on with VSEPR next time.